Hello, everybody. It's Tyler with 3D Printing Basics. If you guys were interested in getting every single episode of this podcast, 3D Printing Basics, ad-free and a week early, and also getting exclusive perks such as exclusive episodes that only you can listen to and more, then subscribe on Patreon. My link will be down below. I would really appreciate it if you guys would consider supporting me. All the support I've already received has meant the world to me, so thank you guys so much. If not, no worries. Continue to consume these episodes for free, and I appreciate you listening regardless. So thank you guys very much for listening, and I hope you enjoyed today's episode. Hello, and welcome back to 3D Printing Basics. This is episode number 103, and in this week's episode, we are going to be talking about STL files, specifically how you can spot a good STL file that you can use for 3D printing and it's going to turn out great versus a bad STL file where you're going to have tons of problems, your print is almost never going to turn out right, and you're just going to have a huge headache by the end of it. We're going to be talking about the different things that you can spot that are going to help you identify whether or not it's good or bad, some things that you can change yourself if you need to make it a good STL file, and more as well. But before we get into it, I wanted to announce that I have finally made this podcast a dedicated Instagram. I know it's taken 103 episodes, but I've finally gotten around to it. I've made the dedicated Instagram. It's 3D Printing Basics. I'm going to link it down below. It's going to be 3D Printing Basics or 3D Printing Basics Pod, and you're going to be able to find it and follow it. And I'm going to do a little giveaway. Once we hit 1,000 followers on the Instagram, I'm going to be giving away another 3D printer. I haven't decided what 3D printer yet. Most likely it's going to be a Bambu Lab A1 or A1 Mini, but I haven't decided yet. If you have any suggestions or any printer that you would want to see me give away, please feel free to let me know. But yeah, like I said, once we get to 1,000 followers on Instagram, I'm going to be giving away a 3D printer. So make sure you're following the Instagram so you can keep updated with this podcast, any kind of announcements. You can see clips as well as just general updates for how the podcast is doing, and also get yourself a chance to win a free printer. That never hurt anybody. So with that being said, I hope you guys enjoy this episode, and let's jump right into the episode. So, STL files, we all know them, we all use them. They are an integral part of 3D printing. You cannot 3D print without your STL file or your 3D model file. Some people use 3MF files, some people use SVG files, but I'm going to be all-encompassing them under the STL umbrella. Even though they might be a little bit different, I'm just going to talk about STLs today. You can't print without an STL file. You need a 3D model, and STLs are kind of the bread and butter for what comes to the 3D model files. But not every STL file is immediately 3D printable. You are going to have some problems with some with some STL files. You're going to find that they might be missing some crucial geometry. They might have some floating parts. They might not be designed for 3D printing, or they might be perfect right off the bat. And we're going to talk about some key identifiers that you can look at to help identify whether or not your STL file is good and you can 3D print it right away, or whether or not you may need to make some adjustments along the way. So one thing that we're definitely going to be looking at is how to identify if your STL file is bad. And one of the main giveaways is looking at the mesh of the STL file itself. If you see things like holes in the mesh, overlapping faces, inside out normals, which is just when your file just doesn't look right. It's kind of hard to explain, but when your file just doesn't look right, usually trust your gut. And it can be because of a lot of things. It can be because the file was not designed with 3D printing in mind. Whoever designed the file did not intend for it to be 3D printed, and you kind of came along and wanted to 3D print it. Could be because they designed it before 3D printing was really a thing, or they just never thought of it being 3D printed. And so what happens if you don't fix this file and you just try to 3D print it as it is? You're going to end up with weird gaps, some missing layers, random stringing or blobs, and it's going to lead to a failed print almost every single time. And this is the big problem with 3D printing, especially with beginners in 3D printing. They grab an STL file from any site and they think they can just immediately put it into their slicer and hit print and it's going to turn out great every single time. But that's not the case. It is really crucial that you're able to identify some errors or whether or not your file is good or bad to print. So you're going to save yourself a ton of time, headaches, and also cost. You're going to save yourself some money if you can identify immediately and fix it in the software before you actually get to 3D printing it. Some quick solutions for if you actually have some issues with the STL file. You can use slicer repair tools. I use Bamboo Studio and Orca Slicer for my slicers, and each of them have an automatic repair tool. So if I load a mesh into the slicer that is not good or it's not ready to be 3D printed, it will flash a little warning down in the bottom right corner and it will say auto repair. And if you click the auto repair, it fixes the file the best that it can. It closes any gaps, any holes that are open in the mesh, fixes any kind of weird overlapping instances or some inside out normals. But something that you definitely want to be careful with here is if you're doing something like using 3D scanning in 3D printing. 3D scanning can definitely leave a lot of open holes in the mesh, and auto repairing it is not always the best move. For example, I just had a cone object, so it's like, imagine a traffic cone where I scan the outside of it, right? And when I imported it into the slicer, the inside mesh was not there. So I tried to auto repair it, and rather than just kind of putting an inside mesh like the inside of the traffic cone like I thought it would, instead it just completely messed up the file. It was unrecognizable. Of course, I could go back and undo the fix, but that is kind of just a lesson for you guys. Auto repair is not always going to fix your file. Sometimes it can actually hurt it for the worse. And that kind of leads into my next point of that auto repairing. You can still print a file that is not auto repaired. You can still print it. I've done it before when it's added some details or taken away some details that I didn't want. If you tweak your print settings or if you minimize, your line widths, your default line widths, the outside wall, inside wall, you can play around the settings and see if you can get something that you really want. But you can print without auto repairing, but most of the time I would suggest auto repairing just because it's a good tool to have. It's good to have repaired, fully functional STL files, and it's just good to have. So that's definitely something that I would consider. You can also use tools like Mesh Mixer. You can use NetFab. These are some mesh editing tools where you can drop your STL file directly into the software and then you can play around with the mesh. You can fix it. You can do something like that. You could also drop it into your CAD software like Fusion 360, Tinkercad, SolidWorks, whatever you're working with, and then you can kind of repair it from there. Although I will say, with my experience with Fusion 360, it is difficult for me to edit a STL file directly in there. It's hard for me to start with a 3D model file and kind of edit it in the CAD software. So if you have any tips for that, please let me know. I'm definitely open to any kind of advice that you might have for that. I definitely am one to admit that I am not an expert 3D modeler. I am getting better and better, but I do not know everything. And I would say out of all the facets of 3D printing, 3D design is probably my weakest aspect. And so I'm always learning to grow there. So if you have any advice for me, please leave it down in the comments below. I would definitely really appreciate it. Another big problem that you are going to find with bad STL models is going to be the overcomplication of these models. So you're going to have models that have either millions of polygons, lots of triangles. They're going to be super, super complicated, and they're also going to be a large file. I'm talking gigabytes worth in one file, one 3D model. They're going to have complex meshes, lots of tiny details, and overall, that can really hurt your print. Not only is the millions and millions of polygons really hard to go through and kind of slice for your software, so it could cause a lot of strain for your computer as well as just take a long time overall. It also can elongate your slicing times, so it can make your print go longer than necessarily it needs to. You can have some you have no visible improvement in your print quality because at the end of the day, 3D printers can only print such fine details. There's a certain point where your 3D printer just cannot print any finer details than what is there. And chances are, if you have a 3D model that is relatively small and is millions and millions of polygons, there are going to be some details in there that the 3D printer just can't do. It's just not able yet to have the technology to be able to print things so small and so fine. Maybe with your SLA printer for sure, but I'm talking just with FDM printers, you might have some issues there. And so at the end of the day, those added small details and the millions and millions of polygons are at the end of the day not the best option for your STL file when you're 3D printing. And some options to kind of fix this: you can simplify your model. You can do it in most CAD softwares, or you can do it directly in the model. I have done this before where I've I've simplified models by up to 50%, and I've seen no actual reduction in the surface quality, which is what I'm looking for when I'm reducing, because I get worried when I simplify and take away some of these polygons that the surface quality or the surface mesh is going to suffer. But I've been able to reduce it by up to 50%, usually when I'm 3D scanning something, because when you 3D scan parts, it creates millions of polygons, and there's no actual degradation in the surface mesh. So that is definitely something to consider. Overall, it's not as big of a deal as STL's coming out with the holes or the gaps or what I talked about in the first kind of section, but overcomplicated mesh models can definitely hurt your 3D printing and can definitely contribute to a bad STL model. The last kind of topic that we're going to talk about is something that definitely I've struggled with, especially when you're working with customers who want a part. So obviously they have their units in mind, but they haven't necessarily clarified their units with you, is that STL models often have poor scaling and their units are all over the place. So some people will design a CAD software that uses inches, some people will design in a CAD software that uses millimeters, and then they'll send it off to you without any clarification. And so when you open up the model, you might think it's the right size, but in reality, this was designed in inches and what they want is in millimeters. And so overall, your product or the STL model is scaled to inches, which means it's not correct and it's not right for the millimeter part. And that is because the slicing software and the design software are using different units. And when you have that, that kind of creates the miscommunication and the misconception of the scaling of the part. So I've scaled parts in, I've dropped STL files that customers have sent me into my slicer file, and it's literally become a pinpoint. I drop it in and it's a pinpoint. Like we're talking less than 0.5 millimeter, big, long, wide, thick, tall, all of that. And I have to either scale to inches, which is an option in your slicer software and works more often than not, or I have to ask them what the desired size of their model is supposed to be so that I can scale it up properly. Another problem that you're going to have is that with the units, they can also come in and be gigantic, like 50 times bigger than the actual build plate can handle. And so you're going to have the same problem there of either you can scale it down to millimeters there, because when it's too small, usually it means it was designed in inches and your scaling unit is in millimeters. And if it's too big, it's because it was designed in millimeters and scaled at inches. And so you're going to have the same issue either way, whether you're either going to have to check with the person or check with the file itself to see what the desired inches are, the desired units are, because it's not always in inches, sometimes it's in millimeters. You're going to find the desired units and then scale it up appropriately, or you can scale up or down from millimeters to inches. So that is definitely something to consider. But those are kind of the three main things that I want you to look at when you're looking at STL files, whether you pull them from Thingiverse, what's it called? The Prusa, it was Prusa printers. It's not Prusa printers anymore. I can't remember what it is, but the Prusa forum for where you get your STL files. There's tons of other STL libraries like that. Some are paid like Colts 3D and some are free like Thingiverse. Whether you're pulling from there, whether customers are sending you files, or whether you're creating your own files. These are all things that you can look at after you make the STL file and drop it into your slicing software, just to check everything overall to make sure you are getting a good STL file and there's no issues with it, so you can have as smooth of an experience 3D printing it as possible. But now that you know what to look for, I'm very confident that you'll be able to drop all your STL files in and immediately spot if there's a problem and get it fixed, and so that you can get your 3D printer running as smooth and efficiently as possible. And with that being said, that's all I have for you guys today. I hope you guys enjoyed today's episode and learned a little something about how to check the STL files to make sure that everything is looking good before you start printing. That way you can save yourself a lot of time, definitely a lot of headaches, and some money as well. So like I said, thank you guys for listening. Again, follow the 3D Printing Basics Instagram. I will link it down below. And once we hit 1,000 followers, I will be giving away a 3D printer. So thank you guys so much for listening, and I'll talk to you guys next time.